Welcome back, and today let's solve Leetcode problem 2099 titled Find Subsequence of Length k with the largest sum. So we're given an integer array nums and an integer k, and we want to find a subsequence of nums of length k that has the largest sum. And we can return any such subsequence as an integer, as an integer array of length k. And they could just quickly define what a subsequence is. Basically, it's an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. So basically, we have to preserve the relative order of these elements that we do choose from our maximized sum subsequence of length k. So in this case, in example 1, we have our input array nums to be 2, 1, 3, 3, and k to be 2. Effectively, we want to have subsequence of length 2 with its sum being maximized. And kind of just to generalize how we maximize sums, whenever we try to maximize sums, we want to have the largest values possible to then have the largest sum possible, right? And so effectively, since we're told that our subsequence output is going to have length k, we have to really try to find the k most largest elements to have the largest possible sum from the k different elements across the input array nums, right? Effectively, this problem can be kind of converted into tell me what the k largest elements are, or rather the top k elements are in the input array nums based on value, and return them with their corresponding indices, preserving their relative order, that is, right? And the reason why 3 3 is our output is because the two 3's are indeed the two largest elements across this input array nums, and we do 3 3 because that is the order that they're listed in the input array nums. We have this 3 here and then another 3 right after it. That's why we have exactly two elements, because k is equal to 2, and that maximizes the sum of 6 because 3 and 3 are the two largest input integers in their input array nums. Applying the same logic to examples 2 and 3, we see that -1, 3, 4, and 3, 4 are the outputs here. Basically, we just want to have the largest k elements from our input array nums, or we're allowed to have duplicates as long as we have that many elements, that many type of elements in the input array nums, and simply just return them as our subsequence. And we also have to preserve their relative order in the input array nums as we actually return the subsequence, because that's how a subsequence is defined. So in our constraints here, we see that the length of our input array nums is going to be between 1 and 1000, and the value in the input array nums is going to be between -10 to the 5th power and +10 to the 5th power, and k itself is always going to be less or at most equal to the length of input array nums, which brings us to how do we really solve this problem? Well, in theory, this really is just a simulation problem here, kind of just converting what the problem tells us to however we want to interpret it, where really instead of trying to maximize the sum, we're just trying to find the top k most largest elements across the input array nums to have then, as a result, the highest sum possible. And usually, when we want the top k elements based on value, we always try to sort them to get them in a very easy fashion, but we can't just directly sort and return the top k elements because we also want to return them with their relative order in the original input array nums preserved, right? Because that's how a subsequence is defined, and so we also have to pair each element with its index as well. So when actually returning the top k elements based on value, we also sort them based on their index values to get them in which order they're actually appear in the input array nums to preserve the relative order of the elements that we actually return with the highest possible values as well, right? So effectively, on a high level, we simply just pair each element with its original index and store them accordingly in an indexed nums array. Then we sort the pairs by their value in descending order to easily get the top k highest values, basically just the first k elements, and then take those top k elements or these highest k values after we sort them based on descending value, and then sort the k elements by their index to then preserve their original order and return those values only to be the top k values, then sorted by their index in the input array nums to preserve that relative order and define what a subsequence is, right? So the first part of this is to actually pair each element with its original index for actually returning the subsequence, and so I'm going to call it index nums. And basically, it's just going to be something called list comprehension here in Python. It's going to be a tuple of length 2, every value or integer or num mapped to its corresponding index. I'll just say IDX for short, for every index and number in the enumerate, which is really just a looping kind of method in Python that maps or keeps track of every index and character or number that we iterate over across an iterable. In this case, that iterable would be nums, right? We're simply pairing each value in the form of a tuple of length 2 with multiple tuples for all the input integers and indices in the input array nums and storing them in this index nums array, right? Then we have to actually sort the values by their decreasing elements to then extract or take out those k largest values, right? Right now we don't care about the index themselves, we just care about the k largest values in terms of actual values, right? So we'll say indexed nums, we'll pass on the sort method here, or dot sort in Python, and we have to actually pass in a key because we're sorting by descending value and not the standard ascending value. Instead, it's going to be descending, and so we're going to pass in a key to be a lambda method, which is just an autonomous function or anonymous function. That's a one-time use method here. It's going to have one parameter x, and we're sorting by negative x at index 0. Basically, we're mapping index 0 to be the actual number itself, or the value, rather than the index, which would be index 1. So effectively, we're sorting by x at 0, or every value across the input array num, or rather every single value in the index num's index, but we're also sorting it by its negative to get it in descending order, right? And we're using this key lambda method to just do it in place, right, if you will. So here we're basically just sorting every single value based on its actual values in descending order to easily get the top k elements based on value, and as the frontmost k, or the top k elements that are going to be the first k elements with the highest value, right? So I can call them top k to actually extract those highest k value elements, which would be the first k elements of the index nums sorted array. And in this case, it would really just be sorted, because we have to sort them again, this time based on their actual indices, indexed nums from or up until k, right? So basically index nums from the 0th index up until k would give us the first k elements, or basically the first k elements with the highest values, or the top k elements based on actual values. That's why we sorted in descending order. And in this case, we also have to pass a key, because we're taking those top k elements once we actually extract them and sorting them by their index. And so in this case, the lambda method here, it's going to be x still, but x at index 1, to then sort those highest k values based on their original index. And so this time the key is going to be x at index 1, right? And once we actually get those top k values, we simply have to actually extract the values. And so the way we do that is returning a list every single value num for every number and index in those top k values, right? So for every single number and index in the top k values, we only want to return the actual numbers themselves, which would be sorted by their indices as we see on line 5, and would also be the k highest values as we handled on line 4, right? So unless I made any syntax errors here, this should be accepted, and this should be a valid solution. Okay, simple syntax error here. Let's see what happened over there. Index nums. Oops, okay, so it should be indexed nums, not just index nums. Just a silly naming convention error there. But as you can see now, this is just about as efficient as you can get it to be, right? So for the runtime and memory complexity here, the runtime complexity, very straightforwardly, is really just linear. Really, we just go through every single element, technically more than once, but since none of the loops are actually nested, it is just a big O of n or linear runtime complexity. And the same can be said for the memory or space complexity, which is also linear or big O of n. Why? Because we do have this extra index nums and technically this top k as well, but since they're not nested, they're each big O of n. Although it's technically big O of 2 times n for the complexities, they simplify down to big O of n, or linear for both the runtime and memory complexity, because coefficients and constants do not matter in runtime and memory or space complexities for data structures and algorithms, right? So it's going to be a big O of n or linear solution for both the runtime and memory or space complexity of this solution. So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.